In this tutorial we're looking at a special matrix called the identity matrix. We have to multiply, and there's some examples here, so let's start. We've got to multiply out this by this, so we multiply rows by columns. 1 times 1 plus 2 times 0. 1 times 1 plus 2 times 0 is going to give me a 1. Then rows by columns to get the entry here. 1 by 0 plus 2 times 1 is 2. Multiply rows by columns to get the result here. 3 times 1 plus 4 times 0 is 3. And rows by columns to get the result here. 3 times 0 plus 4 times 1 is 4. Let's do a couple more. To get the result here, we multiply rows by columns. So it's minus 1 times 1, that'll be minus 1, plus 2 times 0, minus 1 in all. Rows by columns, minus 1 times 0, plus 2 times 1 is 2. Rows by columns, 1 times 1 is 1, and 1 times 0 is 0, and rows by columns, 1 times 0 plus 0 times 1 is 0. I wonder if you've noticed this in these two examples. The matrix we get for our answer is the matrix we started off with. I wonder if it works in this case where we've got the 1, 0, 0, 1 matrix first. Let's try. So it's rows by columns. 1 by 5 plus 0 by 3 is going to equal 5. Row by column. 1 by 10 plus 0 times 4 is 10. 0, this row by this column, is 0 times 5 plus 1 by 3. And this row by this column is 0 times 10 plus 1 by 4. And the matrix we get for our answer is the same as the matrix that we multiplied by. So this special matrix here, when you multiply by this matrix, the answer you get is exactly the matrix that you were multiplying it by. This matrix is called the identity matrix. So what do we notice? When you multiply by the identity matrix, which is 1, 0, 0, 1, you get the matrix that you started with. There's some information about identities. Let's have a look at another question here. What do you think a 3 by 3 identity matrix should look like? Well, here's a 2 by 2. I wonder if you were thinking this. 1, 0, 0, 0, 1, 0, 0, 0, 1. Now the important thing is that it's a square matrix and it's got all zeros except for a line of ones down that main diagonal. Now we're asked to test that identity matrix on a made up 3 by 3 matrix. So you can make up any 3 by 3 matrix you like. I'm going to use the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to times it by my 3 by 3 identity. 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, I'd like you to try one for yourself. You can either use mine or your own. You can either do this multiplication just by hand, or you can do it on your calculator if you wish, but I would like you to see what you come up with. I'm just going to pause the tape just for a moment now. Well, my one seemed to work. I wonder if yours worked as well. Last thing that we're asked to do here is to check that it works. Does it work for rectangular matrices? Now when you're doing this sort of matrix, you should always check. For a multiplication to actually work, the number of columns of the first matrix must match the number of rows of the second matrix. Now this is true. We've got 2 columns, 2 rows, so it should work. And I'll multiply the first row by the first column to get an entry in this matrix here. So it's 1 by 2 plus 0 by 1, that equals 2. I'll multiply this row by this column. 1 by 0 plus 0 by 3 equals 0. This row by this column, 1 by 3 plus 0 by 4 has to equal 3. Now I'm going to multiply this row by this column. 0 by 2 plus 1 by 1 is 1. 0 by 0 plus 1 by 3 is 3. And finally, this row by this column, 0 by 3 plus 1 by 4 equals 4. And you can see that the identity matrix worked because the matrix that we've ended up with was the same thing that we were multiplying it by. If you do that multiplication in the opposite order, in other words, multiply this by an identity, we need to use a 3 by 3 identity because the number of columns in the first matrix must match the number of rows in the second matrix to be able to do any sort of multiplication. Now when we do it, let's see what we get. We're going to multiply rows by columns. Multiply this row by this column. A lot of the entries are 0, so the only one that counts is the 2 by 1 equals 2. And we're going to multiply this row by this column, and I think you can see with all those zeros there, it's only the middle multiplication that's going to count, and it's a 0 by 1 in any case, which equals 0. Multiply rows by columns. 2 times 0, 0 times 0, 3 times 1 is 3, and you can see how it's all turning out, can't you? Multiply this row by this column. 1 times 1, 3 times 0, 4 times 0, it's going to equal 1 in the end. This row by this column, 1 times 0, 3 times 1 is 3, 4 times 0, it'll be a 3 there, and surely just multiply this row by this column, we get a 4 here. And so you can see that the identity works for rectangular matrices as well.